Hello everyone, we are Team Minions.
Every year, countries like Sri Lanka face the devastating impact of floods and landslides. During a disaster, the problem is not only the disaster itself. The real challenge is coordination. Help requests come from many places at once. Some people send text messages, some call emergency numbers, some share photos, voice notes, or give incomplete location details. Many requests are emotional, unclear, or missing important information. At the same time, rescue teams, volunteers, relief centers, and government agencies must decide who needs help first, what resources are required, and how those resources should be delivered. In these situations, delays can cost lives. Traditional disaster response workflows often depend heavily on manual coordination. Information may be scattered across different platforms, and responders must manually read, verify, prioritize, and assign each request. This becomes extremely difficult when hundreds or thousands of people need help at the same time. Another major challenge is resource allocation. During floods and landslides, resources are limited. There may be only a few vehicles, limited medical supplies, limited food packs, and damaged roads. Sending the wrong resource to the wrong place wastes valuable time. Replanning routes too often also creates confusion for field teams. Connectivity is another serious issue. In disaster zones, mobile networks may become weak, overloaded, or completely unavailable. This means affected people may not always be able to access online help when they need it the most. That is why disaster response needs a smarter, faster, and more reliable decision support system. This is where ResQConnect comes in. ResQConnect is an AI-powered, human-centered disaster response platform designed for floods and landslides. It helps transform unstructured citizen help requests into clear, actionable response tasks, supports responders in understanding the situation, prioritizing urgent needs, allocating resources, and providing guidance to affected individuals. But ResQConnect is not designed to replace human decision makers. It's a decision support platform, meaning human coordinators will always remain in control. The system analyzes information and supports faster decision making, while the final approval stays within authorized personnel. ResQConnect is an end-to-end AI-powered disaster response decision support platform designed for floods and landslides. The platform connects affected individuals, response coordinators, volunteers, and relief resources through a single workflow. Citizens can submit help requests through the mobile app, while coordinators can monitor, review, and manage response activities through the web application. Once a request is submitted, ResQConnect analyzes the situation, identifies the required support, recommends response tasks, supports resource distribution, and provides safety guidance through the chatbot. The system is designed to assist human coordinators and not replace them. All critical actions remain under human review, ensuring that disaster response remains safe, accountable, and practical. The first main component is the agentic RAG workflow. During a disaster, help requests are often unclear, emotional, incomplete, or mixed with multiple needs. The agentic RAG workflow converts these unstructured requests into structured response tasks. It first extracts important details such as the disaster type, urgency, location, affected people, and required resources. Then it retrieves relevant information from trusted disaster response knowledge sources such as standard operating procedures, safety guidelines, and operational manuals. Like a standard RAG system, it does not depend on one simple search. It checks whether the retrieved information is useful enough. If the context is weak, the system reformulates the query and searches once again. Once enough reliable information is available, the workflow generates a clear task breakdown with resource requirements. This may include actions such as evacuation support, medical assistance, food and water supply, shelter support, or road clearance. This component helps coordinators quickly understand what each request means and what actions are needed. The second component is the resource distribution workflow. After the system identifies what help is needed, it supports the decision of how available resources should be assigned. In disaster situations, resources are limited, so the system must consider urgency, distance, available inventory, vehicle capacity, and route conditions. ResQConnect uses an adaptive event-triggered resource distribution approach. This means the system does not fully recalculate routes for every new request. Instead, it checks how disruptive or urgent the new request is. If a serious medical emergency appears, the system may recommend a route update. But if a less urgent request can be added to an existing route without a major delay, the system suggests a smaller adjustment. This improves response efficiency while reducing unnecessary route changes. The final output is a recommended resource distribution plan showing what should be sent, where it should go, and which vehicle or team can support the request. The third component is the edge deployed chatbot. This component is built for the mobile app and is especially important when internet connectivity is weak or unavailable. During floods and landslides, mobile networks may become overloaded, damaged, or even unstable. In those moments, users still need access to basic safety guidance. To support this, ResQConnect includes a domain fine-tuned, lightweight language model that can run directly on the mobile device. When the user is offline, the chatbot can still answer basic disaster-related questions without depending on cloud services. The offline chatbot does not make any official emergency decisions. It provides general safety support within a controlled scope. This makes the mobile app useful even in low connectivity disaster environments. The final and fourth component is the Reinforcement Learning Optimized RAG chatbot. This component improves the efficiency of the chatbot's knowledge retrieval process. In a normal RAG chatbot, external knowledge is retrieved for almost every user question. This can improve accuracy, but it also increases response time, token usage, and system cost. ResQConnect uses reinforcement learning to make this process smarter. Chatbot learns when it needs to retrieve new information and when it can safely answer using the existing conversation context. For example, if a user asks a follow-up question about something already explained, the chatbot may not need to search again. But if the user asks about a new disaster-related issue, it can retrieve fresh information from the knowledge base. This reduces unnecessary retrieval, improves response speed, and keeps the chatbot efficient while still maintaining reliable answers. The results show that ResQConnect performs strongly across all main components. For the agentic RAG workflow, the system improved over standard RAG across all 5 evaluation metrics. The overall score increased from 61.4 to 82.9, showing a 21.5 gain. This means the agentic pipeline produced more relevant, safer, cleaner, and more useful disaster response outputs. The adaptive event-triggered routing approach also showed strong practical advantage. It stayed close to continuous re-optimization in response time while using around 75% to 85% fewer solver calls. It also reduced unnecessary route instability, making it more suitable for real disaster operations where constant replanning can confuse field teams. For the Edge LLM, fine-tuning improved disaster guidance quality across BLEU, RogueL, F1, and semantic similarity. The model also ran efficiently on a mobile device, reaching 54.3 tokens per second, with only a small memory increase during inference. This shows that offline disaster guidance is practical, even when internet connectivity is weak. The RL-optimized RAG chatbot achieved the highest composite utility score compared with always retrieve, always skip, and heuristic routing approaches. It preserved most of the answer quality of always retrieve while reducing retrieval cost by about 42%. This means the chatbot can answer efficiently without searching the knowledge base unnecessarily. The system performance results also show that the web application can complete the full workflow with a median time of 12.1 seconds, while the mobile LLM achieves an average response latency of 412 milliseconds per prompt. Overall, these results show that ResQConnect is not only accurate but also practical. It improves task understanding, resource routing, offline guidance, and chatbot efficiency while keeping the system suitable for real disaster response environments. The usability study conducted showed that ResQConnect is practical and easy to use. With a SAS score of 75.2, the system achieved a good usability rating. Users found it easy to learn, easy to operate, and confidence building. Most importantly, the platform did not feel overly technical, which is essential for real disaster response environments where responders, volunteers, and affected individuals need to act very quickly. Overall, the SAS results show that the ResQConnect system is not only technically strong but also usable by real people in high-pressure situations.
Let's now take a look at how an affected individual would use our system. They will be first directed to the Request Help page. And here, they can select the disaster, give the help request a title, and then type a description. They can share their location and add photographs for more context. Furthermore, they can add a voice note as well. And once the help request is complete, they can submit their help request. And as you can see, the track requests page will have their help requests so that they can track these. Furthermore, you have a map option that lets you look into resources, disasters, and requests, and a chat option where you can get help from our rescue bot, a tailored disaster chatbot. Furthermore, you will also have disaster-specific chats connecting all of the community.
Let us take a look at what sort of dashboards the admin has access to. The first dashboard the admin will be directed to gives an overall overview on the entire system. The task status distribution, the number of users, the completion rates, the user satisfaction levels. And next, moving on to the task suggestions. So for all the affected individual help requests, tasks have been generated and they are waiting for the admin's approval. So if this task is to be approved, the admin will simply click on Approve. The task will be approved. Next, moving on to the resources. The admin also has an overview on all the resources that are available and also the number of requests. So as you can see, the current supply snapshot is visible. And also, along with the task approvals, the resource allocation approvals are also a job or a task of the admin. And the admin has the ability to run the allocation plan. The distribution tab gives an understanding on the resource distribution. So as you can see, the incident requests, whether they're served, unserved or assigned, the urgency, everything is being shown here. The delivery routes show the active delivery routes where the paths to be taken are given and shown in detail. Next up, we have inventory and fleet, which gives an overview on the inventory. And finally, analytics gives us an analysis on the overall distribution process.
Let us now use Rescue Edge, the mobile app. You can request for assistance by describing the emergency, selecting the disaster, giving a title, and typing in the details. Set the location and send your request. The request has been submitted. Now let us use the Rescue bot. Here you can type in any question that needs an answer and hit send. Rescue Edge AI would now give a comprehensive answer to your question. Floods and landslides will continue to threaten vulnerable communities, especially in countries like Sri Lanka. ResQConnect brings together AI-powered request understanding, agentic retrieval, adaptive resource distribution, offline mobile guidance, and human-centered decision support into one integrated platform so that we can face disasters better. And most importantly, it supports faster, safer, and more informed decisions when every second matters.